Every company I know has a continuous improvement culture. We strive to make things better and better every single day, every one of us. If you agree, then this is the right course for you, because we're going to talk about Lean Six Sigma fundamentals and how it can provide some structure to your continuous improvement efforts. My name is Syed and I'll be the instructor for this course. I've been in the training industry for a little over 20 years and I've trained thousands of students over the course of these years. In this course, I'll teach you how Lean principles and tools can help you reduce waste and speed up processes. I'll show you how the Six Sigma method can decrease defects and variability within your processes. And importantly, how these two concepts integrate with each other to guide continuous improvement within your projects. Improving business processes is all about having the right tools in the right place and knowing how to use them. And understand and implementing these tools, you'll be able to significantly impact your work business processes. So I'm going to cover a lot of the statistical tools as well, so that it gives you the ability to understand and gain solid understanding of Lean Six Sigma, not only the concept, but actually some of the fundamental tools that you as a manager would require. Who's this course for? I've designed this course for complete beginners. So if you are new to the Lean Six Sigma, green belt field for instance, perfect. This is the right course for you. If you are an existing project manager, maybe managing small projects, that's even better. This course is for you. If you have some experience or intermediate or expert level expertise, maybe you'll gain some tips and techniques from this course. But I highly desire beginners, individuals who wish to learn more about Six Sigma and Lean fundamentals and have gained solid understanding of these concepts. I value your feedback. Post your questions in the discussion area, and that's the best way to learn. So I welcome you to this course. Enroll now, and I will see you in class. Every company I know has a continuous improvement culture. We strive to make things better and better, always. So if you agree with me, then this course is for you. We're going to talk about Lean Six Sigma in this course and how you can provide a structure to your processes. Hi, my name is Syed and I'll be the instructor for this course. I've trained thousands of students over the last 20 years, and as an enterprise project manager with several years of experience, I could do it. In this course, I'll teach you how Lean principles and Six Sigma methodology can be implemented and processes be improved, and you can gain operational efficiency. Let me give you an example. So the concepts of both Lean and Six Sigma are going to be combined within this course, and that's the fundamental of this course itself. So that using the right tools at the right place measures success. So you'll be able to significantly impact the business processes and gain operational efficiency. So let me give you an example about what is Lean and Six Sigma, even though I'm going to talk about this later. But just quickly, take a look at this particular car, right? Well, that's a car, which is a Mini Cooper. So when we manufacture this particular vehicle, most manufacturing companies would like to increase production, right? So they want to sell more cars, During this process, during the manufacturing process, what happens to this? What happens to each of these processes that go in building this particular car? Well, that's an example, right? So as you're building this car, the processes are the ones that you need to focus on in terms of Lean and Six Sigma. And I'm going to talk about what those are, okay? But just fundamentally understand that we are going to eliminate the waste from our processes, like redundant processes maybe, or waste of time that is being spent by these production workers, and so forth. And there's several others that I'm going to talk about. So once you eliminate those wastes, that's really what Lean is all about. Next, of course, you apply the methodology of Six Sigma. Use some statistical tools, do some analysis, gather some data, and then really dish out and eliminate all of these inefficiencies from the processes. So now you have a production within your car and you have an efficient process. So it was introduced earlier by Henry Ford, which was about early 20s, I believe, this concept. Later on, it was adopted by Toyota, which in fact became the powerhouse of production for the rest of the world. Early 80s is when it was introduced back into the United States, and that's where Lean and Six Sigma, in fact, was introduced and boomed within this particular country. So let's dive in and understand a little bit further of what Lean and Six Sigma is. But in this lesson, I just want to cover the course structure, so to speak. I'm going to be covering Lean, Six Sigma interchangeably, all the concepts that you would need to know to make your processes more efficient. So whether you're an IT individual, IT professional, project manager, analyst, or any person who's in charge of certain projects, maybe Lean projects or Six Sigma projects within your organizations, that's exactly the course for you. So I'm going to be covering several topics such as Lean, Six Sigma, methodologies, statistical tools, some Pareto analysis, and some buzzwords as well, because these tools are going to help you use them and then make your analysis. So this course is really for understanding the fundamentals, so you can gain solid understanding of what these principles and methodology is of both Lean and Six Sigma. So let's dive right in and take a look at, in depth, what this course is all about. So I welcome you to this course, and I thank you for enrolling. Einstein once said that you can't solve a problem if you use the same kind of thinking that created the problem in the first place. And that's exactly, fits perfectly within the Six Sigma methodology. And someone mentioned Six Sigma to me, the first thing they usually say is that Six Sigma was invented by Motorola, which is a Google company. But it actually evolved over several years rather than actually being invented itself. So no one person actually sat down with the intention of inventing Six Sigma. It actually gradually developed over time. In the early, let's say 1980s, manufacturing companies were struggling with quality issues and processes and how to make them efficient. Bob Galvin, for example, I believe that was the CEO. He set forth tough quality goals, and that's where the idea of Six Sigma really comes into play. So the whole idea is to provide reliable, consistent, and dependable products to your customers. The process is focused on three things: defects, variability, and the customer. And it's important to understand how these two aspects work together. Six Sigma really began within the manufacturing company to reduce the defects during the processes. So it's not something new. So Japanese companies, for example, in Toyota or other manufacturing companies, they've been doing it since the 60s and 70s. Six Sigma drives basically 3.4 defects per million opportunities. I'm going to talk about what that is later on. So these are not activities, but these are opportunities, right? So about, millions of opportunities. And there are millions of other opportunities of making an error. So for example, if you're building a house, you could have a lot of errors during the entire process from start to finish. And to identify those defects and then make your processes better is the key. So you control the variability. All processes have some natural variability, and that's really the goal of attaining zero defects. And that's the quality concept, basically what you need to implement. Six Sigma is based on the belief that if the variation can be reduced, maybe close to the model specification or your goals, there's less chance for defects. In statistical terms, Six Sigma means that the process variations equal half of the design task, allowing the mean to shift about 1.5 standard deviations. In plain terms, that means your manufacturing processes are very efficient. In other words, the chances of errors are less than 1% or less than 5%. So the process, again, naturally drift, right? So they can't be really perfect. You can't have a perfect process, although you can reduce to a minimum level. So we've talked about defects, we've talked about variability. Where does the customer come in? Six Sigma projects have focus on customers as well. They also provide a structure for the project, such as formal training, formal certifications. That's why we have these various levels of Six Sigma: green belt, white belt, yellow, master black belt. So the focus on the customer, we strive to increase process efficiencies. So as such, Six Sigma can be considered as a very important structured environment. So the company's continuous improvement philosophy is the key of driving this. So this Six Sigma has evolved from this statistic-based management for all companies, and a strategy as well. So you build these strategies based on the results and the outcome of these data analysis. So you can apply these techniques, tools, these analyses to make your processes efficient and of course deliver a quality product to your customer. Clearly, Six Sigma is designed to guide quality process improvement. So most people today don't work in a Six Sigma environment. The foundation really needs to have a solid program which already exists in one form or the other. Companies have solid quality control processes, and that's really the place to start for you as a project manager or as a lean specialist or a Six Sigma specialist or a lean Six Sigma. So if you have, let's say, training or certification in green belt, you are pretty much inclined towards making all of these processes efficient within an organization. So I hope this helps understanding what lean and Six Sigma is all about. So with this, let's move to the next lesson, and I'm going to give you some additional tools and techniques in the next lesson. We will not put into our establishment anything that is useless. And this was said by Henry Ford, which is a good definition when you talk about lean approach. So when you think of lean, most of us think about Toyota production because that's what really made them famous. However, if you really understand, this was actually said by Henry Ford in the early 20s. So the principles of lean production were established by the Ford Motor Company, believe it or not. And that's exactly what Henry Ford wrote. So after some time progressed, lean and JIT, which is just in time, were refined after the Second World War by Toyota Motor Company. And that's what caused the Toyota to become a powerhouse of manufacturing cars for the entire world. So later on, US manufacturers were being seriously challenged in production and producing cars, efficient cars, because Japan was producing hundreds of thousands of vehicles and sending all across the world. So lean is defined as the elimination of all non-value added activities or waste. Although people associate with production, but it's really about waste, how to eliminate waste. Examples, for example, of waste is time, unnecessary steps, activities, rework, waiting time, unnecessary movement of people or even material, and excess inventory. The goal of lean is to find those areas of waste and permanently eliminate them. Lean efforts are really focused on strong efforts on quality process improvement. Lean is facilitated by such things as employees, which really make all the decisions. They're empowered, at least. Highly cross-trained workers, efficient layout of your floor space, standard processes, and then of course JIT, and rapid machine setup. So you're making processes efficient. And we see the benefit of lean in improving your cycle times, greater production, less defects, decreased inventories, and higher level of productivity and quality. So it's not easy to implement lean, by the way, okay? It takes some time, some experience, and efforts. Maybe experts. The focus must be on discipline, and that's the key. So I talked about the goal of lean earlier, is that it's going to eliminate waste within your processes. And that goal connects lean from managing and then continuously improving your processes. So the processes are under continuous review. They're not just one-time elimination and that's it. In fact, you're continually improving these processes. And you can apply it to any process, whether it's your office floor, shop floor, manufacturing, retail. Above all else, lean depends on establishing certain principles. And really, the focus is on simplicity, believe it or not. Most complex processes can be made very simple by eliminating all of these weights. So at Toyota, for example, the most elegant and efficient solution is the most simplest solution. So to truly understand how to implement these lean principles within your company, just look around. See what's being redundant. What are your processes? How you can eliminate waste, such as missed schedules, maybe high rework rate. You identify that right off the bat by looking at certain processes or visiting a certain department. And that's a good start. So with this, I hope this helps. Kind of talked about the history and then understanding further how lean is being implemented. So with this, let's move to the next lesson. Welcome back. Moving forward in this brief lecture, I would like to talk about the Six Sigma Green Belt and give you some resources regarding certification. So if you do choose to pursue that track, that's fine. So here is certified Six Sigma Green Belt, which is also known as ICGB, by the way, is successfully applies to process improvement to businesses and organizations across all industries, whether it's manufacturing, service, retail, and so forth. The Six Sigma Green Belt are experts in identifying problems, analyzing data, and creating solutions to lower costs while improving quality. And that's really what we're going to cover throughout this course, in addition to the lean principles as well, because lean and Six Sigma go hand in hand. So here are some of the responsibilities, not an exhaustive list. I'm going to be covering several additional roles and responsibilities and concepts throughout this course, but just give you a flavor of what green belts do. So they work with simpler projects. So if you're starting off as a basic project manager or a lean Six Sigma manager, that's great. You would be working with refining a project charter, which is a document handed over to the project manager after being approved. You would review the project charter along with the other team members or senior management. You will select the team members for the project, which means resources that you need, maybe experts or other team members from within the organization. You would communicate with stakeholders throughout all stages of the project, and I mean effective communication. Facilitate the team through all phases of the project, which means you will not only manage and provide tasks to the team members, but also act as a leader, okay, and provide that motivation to all of your team members. Schedule meetings and coordinate logistics. Analyze data through all phases of the project, so you will use some statistical tools and understand and apply those tools and techniques, gather data, analyze, and then of course use that result to improve the quality of the processes. Basically, it's a continuous improvement process. And then of course you'll also provide training to the team members. So I just wanted to highlight some of the core responsibilities of the Green Belt Six Sigma. Let me show you the site where you can actually get additional resources, maybe prepare for the test and just read about the knowledge areas. I will also include that as a downloadable resource, so you can download the PDFs, but I just want to show you next. Let me move to the web browser. Perfect. So all you have to do is just navigate to ASSQ.org. Okay, just Google it, you can find it. Here's the Six Sigma Green Belt certification, IASSC, and just scroll through the site. It gives you the costs of the exam, other resources such as the requirements. In other words, you would need some work experience. Our employees who, Green Belts are employees who basically spend some of the time on process improvement teams.
So you analyze and solve quality problems and are involved with Six Sigma, Lean, or other quality improvement projects. So this course basically covers all of the necessary fundamentals that you need for this particular exam. Of course, you need to read up on several other key areas as well. But for the most part, my focus is not strictly on the exam, but just give you a solid understanding of Lean and Six Sigma, Green Belt, fundamental principles and methodologies. So the education and expectations, you can read up on these as well. The body of knowledge you can download. I already have it in the resource area, so just click on the downloadable resource and download it. And of course, other tips and techniques and additional books and materials that you need to read before you actually go ahead and go take the exam. So it's about 110 question exam. 100 questions are scored, 10 are not scored. So you'll have all the details on this site. Okay, so I encourage you to go and visit this site. If you have any questions, feel free to ask. Post it in the discussion area. And I hope this helps. Let's move to the next lesson.
So why do we do Lean Six Sigma? Because you want to do things differently so you get better results. And that's Lean Six Sigma is basically the application of Lean principles and Six Sigma methodology at the same time. But it's a very important concept that you must grasp. So it's not really a specific Lean Six Sigma methodology, but it's really understanding Lean and then Six Sigma at the same time. And few people are really experts at both sides. How Lean Six Sigma is applied is really up to you. You decide how you apply this process. How do you reduce the cycle times, for example? How do you reduce the rework, for example? Some projects need focuses on Lean, and certain other projects, they focus strictly on Six Sigma. The problem itself and your desired results will actually determine the proper mix of these two. Lean and Six Sigma in combination, in most cases, is natural. So most organizations that talk about Lean, Six Sigma at the same time. Along the way, we discovered that there are significant rework that's required, maybe errors committed in different steps, which in turn results in high variations of these processes. So the Lean team now calls in the Six Sigma expert to help take care of these defects and the variability. So over time, the company realizes that all of these actions, Lean Solutions and Six Sigma, combines both of these expertise, really. Many companies, however, believe that you start off with the belief and then you go ultimately towards the Six Sigma. But really, you become a Lean Six Sigma organization. That's really what this is all about. So let's say you were a supplier to a major manufacturing company and you supply, let's say, car engines or any other manufacturing or hardware, for instance. So you are delivering this particular equipment to a large customer, let's say in 15 days, plus minus a week or so. The customer now expects to receive this product, this maybe engine or any of the hardware from you within those 15 days, plus minus a week. Now, if you don't improve your delivery, of course, the customer is going to look for another supplier, and that's fairly common, by the way. Okay, so implementing Lean and Six Sigma within your process methodology, your business processes, to make them more efficient, will entail additional business from the customer and customer retention as well. So that's why the Lean and Six Sigma go hand in hand, and they're very important. So these improvements certainly help variability to some degree of your own processes, but really you're not going to achieve 100% success. So Six Sigma experts actually use statistical tools to determine how you can really become efficient within your processes, eliminate waste. So you use tools like Pareto analysis or maybe regression analysis, whether it's multiple regression or linear regression, and other tools. There are a host of other tools that I'm going to demonstrate using SPSS, which is a software tool by IBM. They can download as a trial and practice tool. So I'm going to give you some hands-on with these tools as well. So you, as a project manager or IT professional or any other person working on certain Lean projects or Six Sigma projects, you understand how to use these statistical tools, how to use software, and then get the results. And based on the results, of course, you can apply and eliminate waste and make your processes more efficient. So in this lesson, I just wanted to focus on why companies or yourself would actually use Lean Six Sigma to make your processes better. So I hope this helps. Let's move on to our next lecture.
The concept of standard normal distribution. So this is a standard statistical concept that I think every Lean manager or Six Sigma manager or even a project should know. Once you collect data and you plot all of your observations, you're going to probably most likely get a normal or a bell-shaped curve. So the curve would look something like this after you plot all your observations. Now what this curve represents is that normality of your data, which essentially means that the bottom part of the curve or any area within this curve, inside the curve equals 1. Okay, so that's the first concept you need to know. So everything within the bell-shaped curved inside the curve totals 1. The curve is also symmetrical. In other words, if I were to divide this curve halfway, right, smack dab in the middle, so that would mean that the left half of the curve is identical to the right half of the curve. And the dividing line of this curve in the center is called the mean, or the mu with a Greek letter. Looks like a U, right? So that's your mean. So basically that's your starting point, that's your 0, okay? So everything to the left of the mean or the right of the mean, if you go to the right side, which is the positive direction, and on the left side of this particular mean is the negative direction. So of course the minus and the plus, right? So think of this as, negative or positive, plus or minus. So far we have two things, right? We have the plotted all of the data that you've collected, and next concept that we discussed was the area of this bell-shaped curve equals 1. Third is the symmetry. So if I divide this bell-shaped curve, both sides are identical, and the middle part is called the mu or the mean, which is 0. The left side is negative, and the right side of that particular mean is positive. Perfect. So next, the fourth concept is the standard deviation, okay, which is signified as the sigma, okay, hence the word Six Sigma, right? So it's the sixth standard deviation. Here it's only shown 1, right? So here's what standard deviation means. That means how much are you deviating from the mean itself. So from the center point, if you're deviating in the positive direction, that'll be the mu, which is the mean, plus 1 sigma, mean plus 2 sigma, mean plus 3 sigma, and of course on the opposite side would be the negative 1, negative 2, and negative 3 standard deviation. So this is really the variability, so to speak, right? How your observations are deviating from the average or from the mean itself. So notice the 1 standard deviation implies that 68% of the observations are within 1 standard deviation of the mean. Similarly, 95% of the values are 2 standard deviations from within the mean, and then 99.7% of the data are within the 3 standard deviations of the mean. So that way, once you plot a normal distribution, hence leading to a central limit theorem, which means that the higher number of observations you have, the more normal or bell-shaped curve you are going to get once you plot all those observations. That's why we take lots and lots of data, right? So the higher the number of observations, you are going to reach normality, okay? So that's important for the concept of normal distribution. And the word standard simply means where we actually use the words mu and the standard deviation. That's why it's called the standard normal distribution. Otherwise, if you just see a bell-shaped curve, that's just a normal distribution. Okay, so just know that difference as well. So I just wanted to quickly cover some of the core concept of what a normal distribution is, what data is, what observations are, what a distribution is. We talked about the mu, standard deviation, the area within the bell-shaped curve always equals 1, the positive and the negative. Of course, this bell-shaped curve can be skewed, which means it can change shape, right? So if it's tilted to the left, that means it's positively skewed. And if it's tilted to the right, that means it's negatively skewed, okay? So I'll leave you at this. Just wanted to cover the core fundamental concept of what a standard normal distribution is. Of course, as a homework that I'm going to assign right now is you need to go and explore more concept of the standard normal distribution, because in statistical analysis, this is important, and of course important for the exam too, if that's what your intentions are. So go ahead, practice with this. If you have any questions, post them in the discussion area. I'll be glad to help. With this, let's move to the next lesson.
So when I sit down to make a course, I need to really, the first thing I do is what to include and what not to include. In other words, define the process, okay? So that's the first step in Lean Six Sigma, is actually defining the steps. When Motorola actually introduced this, they did not really include the define, but rather use the fourth step, which is measure, analyze, improve, and control. The define step was later on added by General Electric because they experienced some basic problems within their methodology or processes. So in this first step, the Six Sigma really defines what the project is and exactly what needs to be accomplished, and that's the define step. So not only just to the production problems, but other areas as well. So Motorola was focusing on different projects where they were focusing on specific areas. And GE also applied Six Sigma to services because they wanted some more processes being improved. And that's really what made these projects go off course before GE introduced this. So the key tool within defining steps is process mapping. So the team can understand what this project entails, and equally important, what is not going to be included in the project. As the project progresses, now you become in depth or more details. So really defining is just establishing the boundaries. You also want to define what to expect, what you want to accomplish, and then the metrics that you want to use, milestones. So let's say if you are successful, how would you know? You exactly need to know the milestones, whether you're achieving those or not, whether you're reducing the defects or not within the manufacturing process or other processes. Most people would agree that Six Sigma must also include a financial aspect, because success is really measured by financial success, right? So if you define this within the earlier on stages of your project, that's really would have an impact on the cost reductions as well. So once you've done this, I would also recommend that you really get the finance department to sign off on these processes. In other words, finance is key, by the way, in the organization. Then we all know, right? They give us our paychecks. So if finance has approved your formulas in advance, your assumptions in advance, it's easier, by the way, to work along with the project. So this financial aspect of measuring is really important in the success of this particular project. But really, we need to go beyond this project and also define the problem. So you want to do it at a high level at this point in time, because the project usually focuses on really something, such as a particular problem or defect or an inefficiency. So the idea is to really go in depth of that particular process and understand the process variability. And that's the problem that your project will actually cater to. So in defining your project and problem, you always want to keep the customer in mind, by the way, because ultimately it's the goal of delivering a quality product to the customer. So from the customer's perspective is what you need to actually think of. Be empathetic. Talk to the customer. Ask them questions. All of their processes should come first. And if there's an improvement that's not important to the customer, well, maybe that's something that you don't want to do at this point in time. So in a sense, in a defined step, you're actually just laying out the issue, laying out the problem, setting the boundaries. And that's really what General Electric made a valuable enhancement to this process. So I just wanted to cover the concept of the first step, which is defining step within the Six Sigma methodology. So I hope this helps. If you have any questions, post them in the discussion area. I'll be happy to answer. So with this, let's move to our next lesson. Welcome back. Moving on to the measurement phase of Lean Six Sigma, right? So we talked about the define in the previous lecture. Here I'm going to focus strictly on the measurement side of things. So if you can't really measure something, you can't really understand it, right? And that's important to know. So you want to understand two aspects of measurement here. What to measure, and then how to measure it. So to do this, you must first know what questions you like to get answered. And this would determine what kind of data you need. Because the measure step of the DMAIC is all about measurement. Where is it? Who can help you find it? How do you make sure the data is accurate? You need to determine in advance what data you need and how to get it. A good approach would be the classical mathematical expression would be y is a function of x. So what is the input you need, which is the x, to determine the output, which is the y? For example, so to determine the throughput of a machine in a factory, you might need to know maybe utilization of the machine, utilization rate, yield, process time. And each of these components can be broken down further and then data be collected. For example, to determine a machine's yield, you want to know, let's say, the scrap rate. So if you are Six Sigma project specialist and you want to increase the throughput of the machine, one question that you're trying to answer is the yield of the machine. And then to do this, how do you do it? You get the historical data from that machine. How to measure is also dependent upon two details. First, how your data is actually being collected. If your quality data is collected in parts in millions, then you want to follow the company's guidelines, for example, right? Or maybe change the guidelines in advance so you know exactly how you accomplish your goals. What are the operational definitions within your company? If you are establishing your performance, then of course you need to make sure that everyone agrees. So let's say I work on, different companies, a consortium of different companies. Each of them have their own understandings. So each one is slightly different methodology, definitions. So you need to make sure everyone is on the same page. And there's a long list of these tools. Key Six Sigma tools include data collection, your process for collecting the right data, and as efficiently as possible. Cause and effect diagram, which helps you determine the right data to collect. Because now you know something like a fishbone diagram, right? Process mapping, which helps you understand the functional relationship with your data. Maybe some other mapping techniques that you want to use. Something like value-added mapping. Process control charts is another tool. Maybe tells you the performance of a certain process as they're being established. Process capability chart is another great tool, which talks about the variability of the process. Histograms is another tool that we use commonly in stats. So there are several tools that you can use. And another final example that I want to give is the Pareto chart, which is the 80-20 rule, right, that you can use. The measure step is not really an easy process, but if you spend time here understanding these tools, understanding the collection data collection methodology, getting the right data, appropriate data, efficient data, then you can apply any of these tools that I just talked about and achieve the required goals. So I hope this helps in understanding the measurements aspect of Lean Six Sigma. So with this, let's move to our next lesson. Welcome back. So moving forward, I'm going to talk about the analyze phase of Lean Six Sigma. So we talked about the define, we talked about the measurement, and here in this lesson, I'm going to talk about how do you analyze things, okay? So you need to understand one thing, which is very important, because you can't find a solution to a problem until you truly, really understand why you're having a problem in the first place. That's really what the analyze process is all about. You focus on the question of why. Why are you experiencing this particular problem? So you want to understand, for example, what is causing the variability within the process, or the unexpected number of defects or errors or trend. So you must have this understanding before you can figure out the actual solution. So you will rely very heavily on the statistical outputs or the results. And that's one of the things that distinguishes Six Sigma from many other quality programs. So quite often the Six Sigma teams would need maybe some additional training and stats. And I'm going to give you those as well, at least at the fundamental level. These are very, very experienced people who actually know all of these tools. And as you grow within Lean Six Sigma, you would actually understand all these tools as well on how to use them. So your goal in the analyze phase is to make sense of all the data that you've collected and evaluate the results and use that analysis to define the source of the problem. So many Six Sigma tools take an even closer look at the data itself. So before you can discover the why of your problem, you must truly understand, importantly, how the existing processes work, how the process should work, and that's important. And you can use process mapping technique to drill down exactly to the nitty-gritty of the process. And you can consider elements such as time, cost, yield, capacity maybe, okay? In the process map, it'll give you a better understanding of how the existing process works. From here, then you can identify how the process should work, okay? So looking at the process map, you can look specifically for the time trends. How are these activities affecting? Maybe the trend is slowing or going faster. And you can take this maybe value stream map to eliminate certain processes. So at this analyze stage, you're actually taking a look at data in a critical manner, looking at maybe histograms, capability charts, Pareto charts, and then different ways where you can identify anomalies within your data. One of the most important tools to master is the 5 whys technique, which helps you to uncover the root cause. And this approach is really straightforward, because once you identify the symptom, then you continue to ask the question why. And then you discover what is actually causing this problem, like a medical doctor, right? Once you determine the root cause 5 times, so you reiterate the process over and over again. So to address the problem is temporary, but to permanently fix, you must address the root cause. Why? Okay? And that's important. So maybe in a training company, for example, or safety incidents within a manufacturing company, you exactly know what actually is causing that particular incident, but why is it being caused? That's important. There's some additional tools you can also use to analyze things. Maybe scatter plots, which basically takes 2 variables against each other and plots them. Time series graphs is another example. You can plot them on the timeline just to identify patterns of certain defects. Maybe ANOVA, analysis of variance technique. That's in statistical terms you can use. So measure of confidence and some regression analysis, maybe create a normal distribution. And we're going to talk about that. I'm going to give you those tools as well, so that you're also proficient with some fundamental tools, statistical tools that you can actually use. So your effectiveness really in the analyze phase is really to improve the problem, right? Not only just to understand what the problem is, but why does the problem exist? So keep that in mind as you move forward with the analyze phase. So I hope this helps. Kind of practice with this. If you have any questions, post them in the discussion area. I'll be happy to answer. And with this, let's move to the next lesson. Welcome back. Moving forward, super excited. I'm going to talk about the improvement aspects of the Lean Six Sigma methodology in this lesson. So before I start, everything kind of evolves around the improvement. And it's one thing to really create a product, but the real thing is actually improving the project over time. And that's really the heart of any Six Sigma project, the improve step. So everything done so far in the DMAIC methodology, which is define, measure, analyze, has led you to the ultimate goal, which is process improvement. Your job is to implement a change that will not only resolve the problem, but also improve the performance and gain operational efficiency. So two major tools that are used here: brainstorming and then communication. Very important. So based on the analysis, you yourself or your team would actually analyze and take a look at or brainstorm. And this is a very good technique in finding innovative solutions that may not be immediately obvious. So before the team can arrive, they must spend some quality time, have meetings to understand this. After the process of brainstorming, then the idea is evaluated one by one, and then you find the solution. And importantly, many times the proposed solution is beyond the defects process or beyond the process variation. So many times the solution also involves eliminating value-added steps. We want to be careful in not eliminating, valuable processes. So many Six Sigma solutions also involve lean applications, okay? Which again are designed to help streamline processes and eliminate waste. And that's why all of the other Lean Six Sigma, like if you're the Master Black Belt, for example, you're very familiar with Lean and Six Sigma methodology. So nothing really changes until you have a successful implementation. And the key is to ensure that you're effectively communicating, which is the second aspect, with everyone involved. All the stakeholders are on the same page. And maybe you're a project manager, and that's important. Because really, within a company, it's human nature, by the way, okay? Because we resist change. So every time you identify, let's say, an issue and you want to create or define or provide a solution to that process, maybe that's not acceptable to the users at first. So you want to be able to have open channels of communications and effectively communicate. And this would give them a feeling of involvement within your project, okay? And their suggestions really could improve the process because they firsthand know exactly how the processes work. Because you're just coming in from the outside, maybe as an expert or as a consultant, right? So you also want to make sure that you have an approval of these processes from all the stakeholders and should have the resources to implement the solution. So the earlier in the stage of this process you involve all these stakeholders, the better. And that's really one of the project management techniques. One of my other courses, Project Manager Fundamentals, I've talked about this in depth. But that's really the key here, is communication. So all stakeholders need to be informed, you need to be transparent, you have to have clear documentation, and take everyone as a team. And this particular, expertise, if you evolve this within yourself, if you gain this skill, it's going to help you a long way. Another project, for example, you could evolve the company-wide training. That's another example. You can introduce short training sessions with all these members within the company. So it's always a good idea to know in advance what kind of support you get from these stakeholders, process owners, end users, and maybe other experts. Remember, brainstorming and communicating is key to the improvement processes. So I hope this helped. If you have any questions, post them in the discussion area. It's always good to engage students, understand their backgrounds. I'll be happy to know exactly what your processes are. Maybe you're working on a certain project or tasks that involves Lean Six Sigma. I'll be happy to hear those. So with this, let's move to the next lesson. Welcome back. Super excited. And the next phase, which is the control phase, is what I'm going to talk about in this particular lesson. So the control phase is the most important step in the DMAIC methodology. Fairly bold statement, but let me tell you why. Control is what enables you to have a continuous improvement organization, really. And every successful company today is continuously improving. No doubt about that. So in the control phase, you make things permanent. So you put in place tools and procedures, documentation, so everything is maintained and change is everlasting. In doing so, you've now established a new process and a baseline for future performance. And now you're ready to improve the process again. Because successful companies follow a continuous improvement philosophy. The control steps really connects the Six Sigma program with all other company efforts: engineering, management, process, financial. The controls you put in place do not have to be elaborate, but maybe as simple as supervisor checklist, review meetings, use of conference call, process charts. If it's a change in SOPs, standard operating procedures, you must ensure that the procedure manuals are updated. And equally important, you must also provide one-point training to end users, to all the stakeholders. The important thing is to have a mechanism in place to ensure that you maintain the improved process. Otherwise, your efforts may not be fruitful because you may slip back to the original process, right? And that's common too, so you want to be aware of that. Since the Six Sigma team is not directly responsible for the process, but it's important that new processes are documented, and I mentioned that earlier too, because you want to provide the documentation so you can monitor the processes as well. And the best monitoring systems are automatic. Identifying and monitoring processes is important. Closely related to effective monitoring system is the control tools like mistake prevention, for example. Mistake prevention means you want to implement procedures that make it difficult to make a mistake from the end users. Maybe computerized forms, mandatory fields that we use in a database, so you don't make errors. This prevents an incomplete forms to be issued or submitted by users. Or you can use mistake proofing. So if you make a mistake, it's not passed on to the next individual. A good example would be maybe, let's say, a restaurant serves you an order, a waiter comes to you and serves you an order, but incorrect order. A mistake has been made, but really you can correct the order. Maybe fast food restaurants is another example, right? Yeah, I'm really hungry. So yeah, exactly. So you get the idea of what that means, right? So you document those as well. So the old process and the new process, both are documented, and then of course you can improve the process, and that's the best way to control the improved process. So this step is now the end of this project, because if you have proper control measures and you verify maybe the financial benefits or the output before you close your project, and now you're really ready to celebrate success because you've successfully went through the DMAIC methodology to close out the actual project itself. If you have any questions, post them in the discussion area. I'll be happy and glad to answer. So with this, let's move to the next lesson. Welcome back. Moving forward, I'm going to talk about the design processes in this particular lesson. You don't need to improve processes because sometimes the existing process is so worse that you need to just kind of throw it away and start with a new one. And sometimes you don't have a process to improve. For example, developing a new product and the processes that go with it. So the design for Six Sigma methodology addresses this particular situation. So improving an existing process, you're primarily dealing with just a single variable. But as you develop methods to make process better, now you're completely redoing the process and designing a new process. And that's where there are a lot more unknowns. And this is the most significant difference between improving the process and designing a process. And in most cases, new processes and products have more focus on meeting customer criteria. Design for Six Sigma helps to ensure that your new product will meet those customer requirements, and the processes can meet Six Sigma rules and capabilities. Your focus is on those attributes that are critical to quality so that it meets the customer's needs. So design for Six Sigma uses methodology of define, measure, analyze, design, and verify, which is again the DMAIC or methodology, which is pretty much similar to DMAIC. But here you're defining first, then you're measuring, analyzing, then you're designing, and then finally you're going through the verification process. And design is important because you specify the details of the new process, you review your progress, and then you further improve, a continuous improvement. And lastly, here in the verification, where you develop a working prototype, you test it, create a plan to implement it, and then make sure it yields or caters to the customer's requirements. So we use such tools like the voice of the customer is a tool, right? So that meets customers' expectation. So the voice of the customer is a set of tools to better understand needs and expectations of the customer. The most common tools is a survey. Yeah, you got it, okay? So that helps get feedback from your customer. So companies use this information to redesign existing processes and create new products and services based on customer feedback, maybe surveys, interviews. And these results of these surveys are used as input to help you align customer requirements and create new products or services or methodologies. So when developing new products, this is a key aspect of quality function deployment. And really it assists the design and manufacturing of marketing a new product and its related processes. So you may come across the DMAIC process by other names, maybe such as DMEDI, define, measure, explore, develop, and then implement. So these two models basically have the same techniques to accomplish the same goals, just different names. So some companies refer to their model as Design for Six Sigma, DFSS, maybe define DFLSS, Design for Lean Six Sigma. So it doesn't matter which variability or titles that you use, essentially the objective is the same. So Design for Six Sigma is really a business strategy that you execute for your projects. There is a much greater emphasis on customer and the business requirements, so that you can create new processes, new products, and then be able to provide them to your customer. So if you have any questions, post them in the discussion area. I'll be happy to help and answer. With this, let's move to the next lesson.
Welcome back. Moving forward, in this lesson, I'm going to demonstrate how to create a Pareto chart on dual axis using SPSS. Of course, you can use Excel, but I'm going to use SPSS, which is a more professional software. You can download it free. Just search for IBM SPSS statistical data editor or download for free. You'll get to IBM site and then you'll be able to download it. Okay. So here I'm going to demonstrate just with some sample data how to create a Pareto chart. So I'm going to click on File, and then I'm going to go on Recently Used Data. So this is called the ice cream data, right? So the different flavors of ice cream that we have. And you can use any data. I'm going to assign you homework as well. But here I have, let's say, an ID column, then the gender, which is female. In this instance, the ice cream types, 1, 2, 3. That means there are 3 types of ice creams, the video and puzzle. If I click on the variable view, I should be able to see the actual labels, right? Or the categories or the labels, the variables for this data. So I have this ID, female, ice cream, video, and puzzle. Each of them are different types of data types. So this is nominal. The top 3 are nominal, and then you have the scaled data, which is numeric. In fact, all of these are numeric data types. Perfect. So in order to create a Pareto chart, you'd have to click on Graphs and then click on Chart Builder. This brings up the Chart Builder dialog box on the bottom. I'm just going to reset here just in case. Next, I'm going to click on Dual Axis, select the dual axis, and just simply drag this chart to the gallery window here. And notice it gives me the y-axis on both sides, and then of course the x-axis, which is the horizontal axis. Also brings up the element properties. If I don't want to see it, that's fine. If I want to see it again, click on element properties here. It's going to bring up the element properties dialog box. So here I have all these variables, right? Remember all these variables that we saw earlier are actually listed here. I can simply drag them wherever I want. So on my x-axis, I like to know the flavors of the ice cream, right? So I'm going to simply drag it on the x-axis. And kind of shows me the preview with example data at this point in time. So bar 1 is now assigned as y-axis, and the statistic is mean. So what I like is simply a count at this point for bar 1, and click apply, and notice this changes to count on both sides. Next, I have the option to click on line 2, which is this particular line that's just selected, which is the line 2. And the statistic here is count. I'm going to change it to cumulative percentage, okay, because I'd like to see the cumulative percentage. The interpolation is either a straight line, step by step, jump or spline. I'm going to leave it as straight. Click apply. And notice on the right side on my dual axis window, or the graph window here, it says cumulative percentage. And then on the left is count, and then of course my types of flavors. So once that's done, click OK. And SPS is going to run the analysis and create the actual Pareto chart for me. Sometimes it just takes a few seconds to do the calculation and pop up. Okay, let's see if it did create. Oh, there we go. Perfect. So here's the output window. So first it kind of tells what the actual commands that it ran. And then if I scroll down, I should be able to see my chart. Perfect. And of course, dual access, right? So I have count, cumulative percentage, and then the flavors of ice cream. I can of course change these values. For example, if the counts, I'd like to change the scale of these, I could change the labels and so forth. So let me in fact demonstrate quickly one, and then you can practice on the others. So I will just double click on this. This would bring up the chart editor window, and then I would again double click on this again to basically have the properties show up for this count. And notice how all of these counts are selected, and the properties window is here. I'll have to go to the scale tab, and here I can change the increments. For example, if I want increments of 2, the maximum of 22, I could do so, and depends. So based on your own data, you can then increment it. Since the data has 95 rows, right? So it can't be 22. I can go up to maybe 100, okay, with an increment of 2. So click on apply, and notice the count axis on the y-axis changes. So that way you can play with it. Similarly, you can double click on the bar itself. You can change the colors. You can sort these values. So right now it's vanilla, chocolate, and strawberry. So they're in ascending order. If you like to sort descending order, select descending, click apply, and it's going to do the descending order as well. And you can close this. So this is a good way to take a look at and use the SPSS. It's very professional, very powerful software. Of course, you can do this in Excel, but since you as a project manager or Lean Six Sigma manager would like to get into SPSS, I would recommend using this and learning this tool as well. With this tool, no matter what kind of data you collect, you can also run regression analysis, correlations, and whole kinds of outputs. For instance, let me minimize this and actually show you what you can do with this. So you can, under the Analyze tab, notice you can do the regression analysis, log linear, classify, scale, the parametric test or non-parametric tests you can do. You can also do AMS, which is another add-on to this, where you can actually run structural models if you really want to get complex. But for this data that you actually collect from within the organization, you can run various tests and do analysis. So that's why I would recommend using SPSS It may take some time for beginners to actually grasp what's all in here, but for now, if you can just practice with the Pareto charts, maybe some other basic charts, and based on the data that you collect. So practice with this. I hope this helps. If you have any questions, post them in the discussion area. And with this, let's move to the next lesson.
Welcome back. Super excited moving forward. I'm going to talk about, in this lesson, importantly, the concept of metrics within the Lean Six Sigma. So when most people talk about Lean, they immediately think of Toyota, right? And the famous production line, production systems. But many principles of Lean production go back to Henry Ford, like I talked about in previous lessons, who really believed that you should eliminate that does not provide any value. Get rid of it. And that's the basic premise of Lean. And Henry Ford also believed in paying attention to details, maybe little problems that left unattended, which actually became big problems later on during the process. So let's move back to Toyota here and just concept of value. So within Toyota, within, let's say, the early 90s in lean manufacturing, several authors outlined key principles in this process methodology. For instance, determining the value for a specific product, and that's determining metrics. Value stream for that product, for example, applying process mapping tools. You can determine the steps that can add value to the product and steps that do not. Make value flow without interruptions. So applying the principles of Lean and problem-solving tools, you're eliminating waste. Let the customer dictate and pull values from manufacturing, which is the JIT concept, which kind of tells you to produce, in one respect, only what you need, right? And pursue perfection. And that's the foundation for the continuous improvement process. Process mapping is also a key tool in this philosophy. The first step here is to draw a picture of the process, a workflow. In this manner, you can easily see the flow of activities from point A to B, and then identify value-added activities. Only after producing a clear map, then you can begin to apply these Lean tools to improve the process. Many Lean performance measurements are metrics of Six Sigma projects. Maybe waste, cycle time, inventory are fairly good examples. One of the limitations is that their tools is not based on statistics. So when variability is the cause of the problem, Lean project managers will call in the Six Sigma folks. Okay, hey, we need help. So nowadays, you need to understand both Lean and Six Sigma applications when determining how to approach a specific problem or process. So most applications in manufacturing, for example, are done that way, and historically that's how it's been. So metrics include improved customer service in every category, better use of machine, better use of people, reduced inventory, higher product quality. And Lean looks closely to things like machine setups, highly trained workers, on-time delivery methods. And most large and medium-sized companies they understand these processes fairly well, because surveys indicate that small companies are most vulnerable. They need to actually apply these tools within their own organizations. So a lot of opportunity for process improvement in small business sector. So you as project managers or individuals kind of focus on these small businesses. Some examples could be reducing a time. If there's a line within a restaurant, how do you reduce the time? How do you make things more efficient? Recently, let me give you an example. McDonald's introduced these kiosks, right, where you order yourself, and then this just, receipt comes out and you take it to the counter, and then you get your food. So whereas actually going to the counter first, standing in line, and then ordering. So now you can actually just go to these bunch of kiosks and just use the screen, touch screen, and then place the order yourself, just get the receipt, and that's about it. So that's a fairly good example in recent times and today's, where you can actually see the process improvement being done using metrics, okay? So I hope this helps kind of practice with these concepts. If you have any questions, post them in the discussion area, and I'll be happy to help. So with this, let's move to our next lesson. Welcome back. Moving forward, in this lesson I'm going to talk about the 5 S's, okay? So moving forward, we need to understand how, after we implement Lean Six Sigma methodologies, how to move about and take a look at the 5 S's and what those are. So you may have heard that simplicity is the ultimate sophistication, and that's said by Leonardo da Vinci, right? Because simplest methodology is good, and Toyota kind of implements this. Lean helps you organize the workplace, commonly called the 5 S's, and that's what I'm going to talk about. So these 5 S's basically is the heart of organizing your workplace. So these 5 S's specifically define a system in organizing and standardizing the workplace. And it comes from the Japanese term, which is sort. Each item is in the proper place. If the item is not needed, remove it. Set in order, which is the second. Arrange materials in tools so that easy to define. Shine, which is third. Keep the work area clean. Remove the clutter. Fourth is standardize. Establish formal procedures to ensure that all steps are performed correctly and consistently. And then sustain. Continue the standardized process through effective training to all users. So, by the way, these practices can certainly be applied to your personal life as well, right? If I'm creating a course, for example, or any other task that I'm doing, I can apply these 5 S's to myself as well. So, the idea is the fact that we need to now take a look at the standardization. The big part is the factory and the operations, for example. So one goal could be to find the best layout for your factory floor or the process floor. So Lean tells you the concept of cellular design. Maybe you want to put a U-shaped desks, right? Or everyone should sit in a single line. If you have different operators, if there are 5 machines, how do you organize them, right? Do you have all these operators in single line, or you create a U-shape, and so on? So you want to be able to use the most efficient method. Whether you want the users to have a line of sight to all these monitors, right? These machines that they're looking at, or maybe you want each person to sit on its own machine. So that way you're reducing manpower, right? Because instead of 5 heads on 5 different machines, you're putting them in U-shape and making 3 workers. So now they have a line of sight to all of the rest of the machines. So that way you can implement these visual controls throughout the factory as well. So if the machine is down, there's an indicator, that every employee can actually see from a distance, and you can take immediate actions. For example, shipping companies, they use visual controls over the assembly plants, okay? So each station would have like lights like yellow, red, green. You've seen those in factories, right? And that's really because everyone can actually see now something is going to happen or something is going to go wrong. Which machines are down, which machines are up. So green, red, yellow are standard lights that we use. You can readily identify. And that particular supervisor or manager can easily identify the status. So shining aspect of the 5 S's is also important. And safety. And safety could be as a 6th S, right? Because that's being advocated heavily within organizations, is safety. So when you think about it, the safety first policy is best supported by making safety really the first S, because that's really should be the key. So implementing and ensuring and deploying these 5 S's is important. And if you do this over and over again, you are going to get your projects to a good start every single time. So hope this helps. Practice with this. If you have any questions, post them in the discussion area, and I'll be happy to help. With this, let's move to our next lesson. Welcome back. Moving forward, in this lesson I'm going to talk about the important concept of JIT, which is just-in-time inventory. So, can you imagine a world in which you receive everything that you need exactly when you actually need it? Not early, not late, but only when you actually need it. And that's exactly what JIT implies. Although JIT strategy is really typically associated with Japanese manufacturing, but like I talked earlier, if you read, notice it was Henry Ford who actually introduced this concept. He did not believe in warehouses, so he bought all materials only enough to, meet the immediate needs. And that's really what the critical factors of success for Ford was. So he had a network of railroads and trucks and so on just to deliver JIT products. So the best practice within the, moving on to 1980s, that's where companies started to use this JIT methodology and excelled in manufacturing, like Dell, for example, Microsoft, and other HP and other companies as well. So the raw materials and sub-assemblies are delivered to the factories just when you actually need them. This allows inventory to be maintained at really minimum levels. So this reduces costs and provides more flexibility to the organizations. So if the item becomes obsolete, just take off of the minimum inventory items and then order them from the manufacturer or the source. So JIT is applied typically in almost all realms. So based on the forecasted demand of the product, you would then implement the JIT strategy. So the customer demands really drives the output and your processes and operations. And this is an important concept to recognize because most industries in the United States, including automobiles, they would run on business accounting principles, okay? Maximizing the output, using expensive machines, using inputs, and incurring more capital costs. So companies ran at maximum production and then hoping that they would sell all the products. The automobile, for example, they introduced new models every year and they had surplus inventory. They didn't know what to do with it. JIT in fact changed all of that. So now you're only requiring those materials to be provided to you as the automobile manufacturer or company that you actually used. So this is controlled by the Kanban system, which is KANBAN. So this system uses a basic communication device simply to notify each workstation where inventory is needed, right? So, the current signals the workstation as to if you're out of something, they would provide it just in time. So that's the core concept. Total inventory is actually reduced and then throughput is increased. So you'd help reduce cost in a more efficient manner. So several key considerations to keep in mind during JIT. A JIT strategy is highly dependent on an effective delivery system, as Ford recognized earlier. The further away your suppliers are, the more difficult, of course, for them to deliver. So one of the reasons why Kanban is more successful because in a relatively small country, they're sourced locally. And one of the reasons why the United States struggled because it's a huge country. And for someone to ship from New York to California, it's going to take time. So that's why JIT is an important and efficient concept. A JIT strategy is dependent on standardized work processes and methods that are consistently performed. Variability is the opposite, the enemy of JIT. And this is exactly where Lean and Six Sigma work together to drive out both variability and non-value-added activities or waste. So there are lots of interconnection using these tools, right? For example, standardized processes support just-in-time practices. As a Lean project manager, you should have a strong understanding of these tools so that you can improve your processes and gain operational efficiency. So a JIT is an important concept, and you implementing Lean Six Sigma methodologies within these processes would further enhance the organization to achieve the utmost levels of operational efficiency. And of course, a happy customer at the end of the day. So I hope this helps. Practice with some of these concepts, understand them. If you have any questions, post them in the discussion area and I'll be happy to answer. With this, let's move to our next lesson. Welcome back. Next, I want to talk about the productive maintenance, or the integration of quality and production, and how does Lean Six Sigma fit into this picture. So a factory cannot function unless the machines are working and available when they're actually needed. So seems fairly simple, but really the total productive maintenance, or TPM, concept is all about. So TPM tries to understand both preventive and corrective maintenance procedures, and to apply those methods in the most efficient manner. And that means that to keep the factory running, TPM practices ensure that the machines will not break down unexpectedly, and scheduled maintenance will be completed in a timely manner. So the goals are simple: to minimize equipment downtime and then maximize equipment availability. The approaches, again, are very closely intertwined between unexpected downtime and periodic maintenance activity are done due diligently. This increases not only production flexibility, but also other changes as needed are also implemented, and ensures fluid flow of material, so to speak. So Lean has made several contributions in this effort, which is reducing the downtime, for example, in this particular area. So I want to give you an example here. So in my experience as a project manager, I used to work for a company where we used to manufacture a certain hardware product, okay? And the machine that actually manufactured that product had to be, periodically managed or maintained. So what the technicians would do, they would typically come over and they say, well, okay, here's when the downtime starts, so we would just stop work, and then they would actually go about doing so. That's fine, and that's typically being done, and no one really knew the implementation of Lean Six Sigma methodology in this particular process. So Japanese, on the other hand, for example, when they came across this particular scenario where they were manufacturing hardware and their machines needed downtime, they did something different. And it's quite interesting what they did. They, in fact, reduced the technician time, or the downtime time, by implementing Lean Six Sigma methodology. How did they do it? Fairly simple. They actually made all the technicians use the tools to fix the machine or maintain the machine, to gather the tools before the machine can be taken down. So now, all of a sudden, you have all these tools placed next to the machine while the machine is running and everyone is working. Then they would take the machine down and then, of course, do the periodic maintenance. So that helps gain time or productivity for the worker. So it may not seem a lot, but yes, if you multiply that with hundreds of machines, right? Let's say you have an assembly line, and maybe you're a chip manufacturer, right? That's the assembly line, or the Apple iPhone assembly line. So that machine that's going to run the quality test on the iPhone product needs to be periodically maintained, right? So think of the amount of time being saved, though on the face of it, it may not look a whole lot, but in fact, when you actually do the calculations or run some statistical analysis on that, you are going to save a whole lot of time and money to your company. So this is just an example of the relationship between quality and then production, and how do you manage those. So I hope this helps kind of understand these concepts. If you have any questions, feel free to post in the discussion area. Also, if you're working on a certain project, I'd like to hear from you. And that's the best way to learn and engage students. So with this, let's move to our next lesson. Welcome back. Moving forward in this lesson, I want to talk about the core concept of quality and how it's implemented. So let's dive in and understand the concept of quality along with the Lean Six Sigma methodology and the processes. So quality is doing things right when no one is looking, really. Because if no one is watching you and you're performing or producing quality product, that's exactly what the goal is. So here, the eliminating factor is the inspection step, right? And that's really becomes a waste because now you don't need inspections. Let me give an example. Let's say you have a automobile production line, and stopping that production line is a costly thing for the organization because you don't want to stop the production. And, it's just like one vehicle and the second one is on the assembly line and third and so forth. So stopping the assembly line is a huge thing. Japanese, on the other hand, astonished the world where they authorized anyone on the production line to stop the entire production line if they want to improve quality or if they see a lack of quality. So it's not the manager, not the supervisor, not the director, but maybe just the line operator can stop the entire production line just to make sure the quality is adamantly, as per the policies to be delivered to the customer. So similarly, just as it used in the Six Sigma methodology, mistakes, is a term or is a thing where you need to improve on and make the system foolproof. And that's a common lean expression is making things foolproof. Okay, so you make sure that the mistake is not made and passed on to the next station. So the impact of quality at the source goes far beyond the quality product at the shop floor. In fact, is the key enabler of just-in-time capability for your company as well. So if dedicated inspection steps are eliminated from the processes, of course, you're going to gain some extra throughput time, which is great. And you can now deliver products to your customers quickly. Of course, just in time, right? So quality of the source within your key suppliers as well also enables you to function properly because now they're also following the same methodology as you are for your customer. So the idea again is to maintain a process that is quality oriented and then it's foolproof as well. So you're not reworking areas, okay? So in short, when a supplier delivers materials to you, to your factory machines, and then that's, utilizing the true JIT manner, same capability is you are following the same methodology for your customers, okay? And that's what makes processes efficient in this highly competitive supply chains. So the idea is quite simple. Focusing on quality does not mean just fixing a process and now you improve quality. Essentially, at the end of the day, you as a lean manager or Six Sigma certified individual or practicing manager, you need to ensure that quality remains without an inspection, and then it goes day in and day out, following a simple methodology. So I hope this helps. If you have any questions, feel free to post them in the discussion area. And with this, let's move to our next lesson. Welcome back. Moving forward, I'm going to talk about more on continuous improvement so that we understand and really focus on the core areas and maintain our core fundamental understandings of Lean Six Sigma. So, like the famous basketball coach said, I believe his name was Pat, right? He said that if you're not getting better, you're actually getting worse. So, great advice from this basketball coach. You simply cannot stand still because your competitors are continuously improving their processes and getting better. So you as an organization also must continually improve. And that's very, very important. Most of us work in a continuous working environment and we use lean principles to some extent without even knowing it. So every lean tool is intended to improve process, reduction of waste, and wasteful activities. The lean expression is Kaizen, which is a Japanese word, means gradual and orderly improvement. Kaizen was intended to, take a look at all of these activities, not just the production, but service industries as well, retail, administration, safety, transportation, new product development. So every other thing that you can think of can be implemented. So any effort that is used to improve any part of the business is actually a Kaizen event. The Kaizen philosophy is really not making things perfect, but making things a little better, right? So step by step. So the principle of this Kaizen is to implement them in a daily life, where you're improving the projects continually, whether it's your own self or your project or your client or your customer. So as such, three important aspects for continuous improvement. The first is operating practices and procedures. Companies typically programs guide daily work, so you come in and work. And they reveal opportunities for improvement. For example, a one-time delivery program improves or reveals a weak process, just like quality process also reveals lack of measurements. Another important aspect is basically the total involvement, and that's important. From top management to end user, you need to encourage the improvement programs. Managers, supervisors, line operators need to work towards improvement. And workers and users participate in these programs, take part in these activities. You must also consider training as well, like self-development programs, classes, workshops. These are very, very important because everyone is seeking to enhance their job or processes related to their job. So if you move into a continuous improvement mode, it's not something that you can, just happens in a week or so. It takes time, but it's important. So if you're looking for incremental changes in these processes, sometimes a situation requires where you want to move faster in a direction. And in that instance, Kaizen Blitz is used, just like the football blitz, right? So in that respect, that particular error or issue must be resolved very quickly. Let's say you have a sudden product recall, and you don't have time to waste. You have to come up with a new product and fix it. And that's where the Kaizen Blitz teams would come in, cross-functional teams would come in, bring in employees from all functional areas, get everyone on the table, right? And then make things move faster so that the new product can hit the market and your customers are happy. And we've seen several examples, whether it's the recall of your phones, whether it's the equipment or automobile part, and so forth. The times are very short, and that's really the key here for Kaizen Blitz. So all team members would come together until the solution is implemented. And this approach has been proven to be very effective, by the way. Okay? So finally here, continuous improvement is really what connects Lean with Six Sigma. Because Lean has certain principles and Six Sigma is a methodology, right? So if you continually integrate both of these and work together, that's exactly what you will achieve as being a continually improved and efficient process. So I hope this helps. Practice with this. If you have any questions, just ask. Feel free to ask. I'd like to know more about your projects that you're working on, and that way, we can learn from each other as well. Other students can also learn, and the best way to engage. So I hope this helps. Let's move to the next lesson. Welcome back. Moving forward, super excited. I want to talk about leadership and learning and the relationship with these two words with Lean Six Sigma. So success, or let me put it this way, to be successful in a Lean Six Sigma, you basically need three things. First, you need leadership from the top, and that's important. You also need skilled expert team members and strong supporting resources and infrastructure. And then, of course, the expertise of the team as well. So the organization has to be committed to the Lean Six Sigma strategy, and equally important, the top managers must effectively communicate that downwards. Different companies have different approaches depending on the corporate culture, but it takes much more than just the official guidelines, right? Management must continuously demonstrate their support through the daily actions, meetings, budgets, resources, rewards to the teams. Let me give you an example. GE and Motorola and other large organizations are great examples where they provide that type of leadership methodology downwards to the teams. So they would apply or reward every employee that would actually gain certification in Lean Six Sigma. Second is the effective communication, because now you need to, apart from the leadership role, provide effective communication to all your cross-functional teams. So the goal is not to change things per se, but essentially improve the processes, right? So providing a leadership role and then, communicating downwards is important. And then third is the team members, right? So every project, Lean Six Sigma project involves skilled team members. So you can gain from their expertise. And then, of course, team members expect the leader to be an expert in Lean Six Sigma principles and methodology, and have demonstrated in previous projects. So you, as a project manager, if you're beginning, of course, you're going to get some experience and you'll get better at it. So when you actually assign employees to certain tasks within the Lean Six Sigma project, that's where your qualities or abilities as a leader or as a manager comes into play. And that kind of goes hand in hand with the project manager fundamentals as well, right? Because a good project manager is not only a manager, but also a leader at the same time, whatever your style of leadership is. So the goal is to have a structured, continuous improvement environment for the company's benefit. So I cannot say enough about providing, the resources to support the infrastructure, because, that's really directly dependent on the output or the success of the particular Lean Six Sigma project that you're actually performing. So training, providing resources, leadership from the top, communication are important. And projects must have all of these systems in place, like financial, planning, recognition, reward, all must be kind of go hand in hand and adjusted for a successful Lean Six Sigma project. So I hope this helps. Practice with this. If you have any questions, post them in the discussion area. If you've been dealing with other projects, kind of post them. Let's discuss them. And that's the best way to learn. So with this, let's move to the next lesson. Welcome back. Moving forward, in this lesson I'm going to talk about managing and actually controlling your Lean Six Sigma projects and how they actually work. What are some of the techniques and best practices? So before I begin, talk about the managing or the controlling part of Six Sigma, you as a leader or a manager, and managing Lean Six Sigma project, your success is really dependent on controlling the project's environment. Like all projects, Lean Six Sigma goes through 4 phases, right, of the life cycle. Initiating, planning, executing, and then closing. In that all-important stage, which is the execution, that's where you monitor and control. So up till now, the PM has been truly managing things, right? Making the proposal, getting necessary approvals, getting the project charter, project plan, schedule, recruiting key team members, resources. So now you need to turn from managing to leading people and events. And this is more than just, leading and finding a solution to the problem. It means much more than that. It means leading the teams to a successful conclusion, the one that actually benefits the company. So now you're controlling who does what. They all report to you. You're assigning tasks, making sure it's a team effort and how well each task is completed. And this involves effective communication more than any other leadership skill, by the way. Communication is key with all team members and the stakeholders, making sure everyone is doing, their job and which direction the entire team is actually moving towards. Continuous communication with all stakeholders, like I mentioned earlier, and top management is important to ensure that you are transparent and your solution can easily be implemented. Communicating with mid-level managers, you need to make sure you have all the resources you need when you need them. So technical expertise is also important, by the way, as a third aspect. So if you run into an obstacle where internal team cannot solve, well, guess what? You need to get the external expertise. So your level of your technical skills and the understanding of Lean Six Sigma should give the confidence to the team members that you can successfully complete the project. Organizations have support infrastructure and other experts they can rely on. They can assist you, by the way, like maybe black belt Six Sigma. They're good at Lean and Six Sigma both functionalities, or Yellow Belt, and so on. So you get the idea. So standard project management skills definitely apply to Lean Six Sigma. So project manager role, skills, and doing analysis like Pareto, Gantt chart, scheduling is equally important. All of these tools help within the Lean Six Sigma. So all of these tools, in effect, allow you to have an effective project review system. And that way you can actually truly control the project in a better, efficient manner. So this safeguards really the project going off guard, right? And the focus remains on the central issue. And equally important is the acceptance of the final solution, because that's the bottom line. The customer who you're delivering the product needs to accept the solution. And your internal team, stakeholders, also need to accept the solution that you as a project manager or Lean Six Sigma manager actually are implementing. So keep this in mind. Continuously consider the closing phase, okay? Your vision should be at the end. So that would help you in controlling your project more efficiently and help you really take your company's Lean Six Sigma program and use it more effectively and productively. So I hope this helps. If you have any questions, post them in the discussion area. I'll be glad to answer. With this, let's move to our next lesson. Welcome back. Super excited moving forward. I'm going to talk about moving forward with the application of Lean Six Sigma. Is just not related to manufacturing only, but also to service. So manufacturing companies also have service operations. And Lean and Six Sigma apply just as readily to finance, engineering, transportation, as they do to production processes. So, for example, Motorola initially did not recognize this particular concept, and they focused strictly on production and cost them billions of dollars. Experts have estimated that almost half of the work done in a typical service process adds no value in the eyes of the customer. So reducing process steps that are not critical to customer quality is a key part of Lean Six Sigma for services. And it's not just about introducing steps to speed up the process. It's actually reducing the waste and the variability to those value-added steps. Of course, variability adds cost times to the processes. A classic example from, let's say, let me give you an example. So in a hospital, each surgeon would have a customized surgeon tray before each operation. So for every surgical procedure in that hospital, there was a different surgical tray for different surgeons. So now you can imagine this kind of complexity just takes time and expense and reduce the flexibility totally. So let's say one doctor had to switch and take position for the other doctor, they'd have to wait and lose time because the new tray needs to come in for that surgeon. So that's not really a medical requirement, but that's more of a management issue, right? And that's something where Lean Six Sigma will come into play and evaluate these processes and fix them. And really, the goal is to provide standardized configuration, right? So all of the concepts that we've been talking about that you would apply as a Lean Six Sigma manager. So this hospital actually used Lean Six Sigma and applied across the board. And in applying Lean Six Sigma tools and service and process in that service, two things happen. First, a slow process is usually caused by too much working process. Complexity causes reports, emails, customers, meetings, conference calls. When there's too much in a system, every item spends, most of the time just waiting in line, okay? That's the first part. Secondly, most slow processes, 80% of the delay is caused by the 20% of the activity, which is the Pareto principle, right? That's the 80-20 rule. And this can help you as a Lean Six Sigma manager to attack this problem. So you want to take the complexity out of the service processes so that you can easily do business with your customers as well as suppliers. So complexity is not really bad, but it can be made simple, and that's really is the goal for you as a manager, to look at the processes and then kind of break them down into simpler steps and make things simple, and that's then easily adapted by the end users as well. That way, the other benefit of having the complexity issue is that you can, better offer the product to your customers if you make that simpler. Maybe the customer has a requirement that is highly complex, but since you implement a Lean Six Sigma methodology to the process, maybe you can suggest to the customer, well, what if we actually did this? Would that help? And let them evaluate and let them come back to you and then identify and say, well, this works. So that way, it's very helpful if you use this methodology. So I hope this helps. If you have any questions, feel free to ask. With this, let's move to the next lesson. Welcome back. Super excited moving forward. Almost nearing to the end of this particular course. There's an old saying, and very important, that if you don't take care of your customer, someone else will. Okay? Acknowledging this, every Lean Six Sigma project touches the final customer in some manner. Either it's quality or cost or time, any one of these manners. So today, Lean Six Sigma applications have gone far beyond spanning functional boundaries across the company and extending across the supply chain. So finding solution and improvements, your projects touch different aspects of the supply chain. Let me use inventory management as an example, because Lean Six Sigma projects for supply chain management commonly focus on some aspects of inventory management. The purpose of having inventory, of course, is to meet demand of your customers. So if you discover a problem with a particular customer order, you may launch a small project as to why you're having this problem. And that's where Lean Six Sigma comes in. So you know up front you don't have the right inventory in the right place on the right time, because in this situation you're not actually delivering to the customer as promised. There could be a number of reasons for this. Maybe poor focus of demand, creating a general inventory shortage. Maybe there's a problem with one of your suppliers for this particular product. Could be a capacity problem. Maybe a problem could be with the trucking or the transportation company that you hired. So all of these areas must be investigated. And when they're linked together, this is your supply chain. So every business has a supply chain to manage. No matter what your company does, you have a supply chain and you perform the same basic functions. So you construct a plan to meet your customer demand. You source the needed materials and the services from the suppliers. Then you make a product, and then you provide a service to your customer. Bottom line is you deliver a quality product. And of course, you get a return from your customer. This is supply chain basic. So Lean Six Sigma inventory project must balance all of these things, such as demand, factory lead time, supplier lead time, customer service levels, supply chain. And this goes beyond the classic cross-functional team. In fact, you need a cross-organizational team. You need experts from different parts of your company or experts from different suppliers or services. Because the solution lies somewhere within your supply chain and not necessarily within your own company. So that's where Lean Six Sigma is clearly not just for manufacturing. It's for services as well. Understanding the key performance indicators are both, is an important indicator. And remember that your company has many supply chains. So let's say an untimely delivery problem, you must know that particular line to cater to that issue. Suppliers, for example, may be quite different from supplying these, products to you. So strategic gaps, for example, discovered through benchmarking through other companies is one of the tools, techniques you can use. Cost avoidance, customer issues, regulatory issues, safety is important, those issues that you can actually take a look at and use. Successful projects, by the way, must be replicated, and that's important for you as a manager. You need to make sure that if you've done a successful project in the past, chances are that you should replicate that because it works and it provides the required benefit. Maybe supplier development programs is another issue where you can talk to suppliers and constantly communicate with them. Make their processes more efficient as they relate to you. So all of these tools and techniques are helpful in your Lean Six Sigma projects. Before you actually begin all of this, by the way, remember you need to draw a process map, right? Because that's sometimes, or in fact very effectively helps you map all of these areas, and then you can easily identify and then implement the Lean Six Sigma methodology. So I hope this helps. Practice with this, and let's move to the next lesson. Welcome back. So in conclusion, Lean Six Sigma is all about the process, making processes better, solving problems for your customers. If you're interested in taking a further look, maybe I'll suggest a few resources. So for example, you need to take a look at lean.org. I'll give you some resources in the website as well, so you know which sites to visit and how to get all these resources. Another one is bptrends.com, ClayDesk.com, eCampus. I have several of those in my own forums that I've listed on the website, and there's several others. So I will provide you a list of downloadable resources that you can actually use this. So leading Six Sigma, managing, and working with Lean concepts and Six Sigma methodology. If you've gained these fundamental concepts throughout this course, I think you're very well equipped in moving forward and starting off with some of these projects on your own. And I've also highlighted a lot of the statistical tools that you can utilize, evaluate the data that you've gathered for these processes, and then effectively implement them. So, in a nutshell, a Lean Six Sigma manager is a person who kind of goes through the entire DMAIC process and effectively understands each and every step. So I'd like to congratulate you for finishing this course and being with me.
So in this lesson, we will learn how to create a new free web host. So let's move forward. I would recommend you to go to ClayDesk.runhosting.com, and on this site you can easily make a new and free web host. So to make a free web host, you'll scroll down and choose the free hosting plan. Click sign up, and it will redirect you to the page where you could fill in your login details and make your free account. So we'll choose ClayDesk free hosting plan, scroll down and click continue. Now it will take you to the page where you have to fill in your login details. So you'll write in your first name, mine is Saeed, and last name Ali, and your company I'll write in ClayDesk, and then your email address. I'll type in my email address and then password. After typing in our password, we have to write our address. I'll write my address, and then my city, which is Piscataway, and then my state. And then we need to write our zip code as well. And after that we need to choose our country. So after choosing a country, it's an optional field if you need to write your phone number. If you don't have a phone, you can leave this field blank. So then we'll agree with the following agreement. Then we'll check this box which says yes, I agree with the following agreements, and write in the CAPTCHA, and then click continue. And it will process our request and send a confirmation email to our email address. So basically it says, congratulations, your web hosting account has been created successfully. Click here to log in. It is ready for you to explore it. So we'll click here, and it will take us to the login page. But first we need to verify our email. So we will open up our email address and then we'll verify our account. So this is the confirmation email and this is the login details. So we'll click on email confirmation, and to activate our account we'll click this link. Now as you can see, our account has been verified. Now we need to enter our email address and then our password and hit login, and it will take you to your main dashboard. So in this lesson we learned how to make a new free web host. Now it's your turn to sign up for your free hosting plan, or you could also take your personal plan if you want to create multiple databases.